Welcome back. Let's share the techniques of answering multiple choice. In front of me, it's a physical sciences, a recent question paper on multiple choices. In this case, we'll be going through and then try to share how can we best answer these questions involving multiple choices, and maybe through the interaction, people will now develop the love of answering multiple choices when the basics are correct. Now, the first question, according to this one, they say three forces act on an object so that the resultant force is zero. Remember, when the resultant force is zero, we are in Newton 1. Therefore, if we have got a diagram like in this one, which one of the following vector diagrams is correct? Is a correct representation of the three forces. Remember, if we've got three forces and we draw them vectorially, then we expect a closed figure, meaning that now we'll check the one that gives us the closed figure. The best one will be number D. Can you see from here to here and then to here, and then this closes the figure. Therefore, D will be the best one. Then next question says this question says two large objects P and R, each of mass M, are placed with their centers R meters apart as shown in the diagram below. They exert a gravitational force of magnitude F on each other. Mass R is increased to 2m, and the objects are now placed so that the distance between their centers is 2r. In this case, remember, if you double one of the masses and we double the distance, so if you want to calculate it in a quickly, will be now from the formula of F equals to gm1 m2 over r squared. Therefore, if everything remains the same, let's say the one that remains the same, put 1, and then the one that is double, you can put 2, the other one remains the same, and then the distance is also doubled. Then in this case, you can see now it's 2 over 4. Therefore, it means that the force now will be halved. So we are looking at which one of the following is the magnitude of the gravitational force that R now exerts on P. It will be half, which will be A in this case. So A is the best one. That's 1.2. We go to the next question. Next question here, they are saying to us in this one, the velocity, if you look at this one, the velocity versus time sketch graph below is for the motion of a ball that is projected vertically upwards from the top of a building. Fine. You can see that now the slope is negative, meaning that we take upward as positive. The ball reaches its greatest height above the ground at a certain time. Which point on the graph will correspond with the greatest height? Remember, at the highest point, the velocity is 0. So where velocity is 0, then we are at the highest point. Then Q and S will be in this case. But here they say which point on the graph correspond to this greatest height is projected. Now the greatest height will be Q. Remember, S is the height reached after the first bounce. It won't be the greatest height. The greatest height will be Q. Therefore, we expect now B to be the best answer. B, and in this case, obviously, if the learner can just write Q, then that one will be accepted. Now, two hard objects collide inelastically. They underline the inelastically, meaning that now kinetic energy is not conserved in an isolated system. Which one of the following statement is correct for this collision? Both momentum and kinetic energy are conserved. No. Neither momentum nor kinetic energy, that one is wrong. Total momentum is not conserved, that one will be wrong. And then total momentum is conserved, but the total kinetic energy is not conserved. I think the best one will be this one. Remember, in all collision, momentum is conserved. So, but it's the energy that can be conserved or not conserved. So the last one, number D, will be the best one. That's 1.4 D. Next question, engine P has a greater maximum power output than engine Q. Which one of the following statement is correct when P and Q operate at their maximum power output? So in this case now, you can tell if the engine P has a greater maximum power than Q. Therefore, which means that now, which one of the statement will be now as they operated their maximum power output? So Q does more work than P in the same amount of time? No. P and Q do the same amount of work in the same amount of time? No. They can do the same amount of work but not in the same time. P and Q do the same amount of work, yes, but Q does it in a shorter time than P. No, because remember Q is less than P. The P and Q do the same amount of work, but P does it shorter time than Q, best one. So it will be D. Then we go to 1.6. 1.6, remember, is Doppler. In the multiple choice, questions are normally related to questions that are in the structured form. The absorption spectra of the same element surround both star A and star B are observed from Earth. No problem. The spectral lines of star B are more redshifted than those of star A. Now, how do the frequencies of the observed spectral lines and the speed of star B compare to that of star A? In this case now, we underline this one to say the spectral lines are more redshifted on B. Fine. What will be the case here? Will star A, frequency of star A be higher than that of B? The answer will be no. Remember, B is more redshifted, so its frequency must be higher. So must be, in this case, the frequencies in this case will be lower because it's the one that is furthest now. Should be lower. I mean that the answer is between C and D. Now what is going to differentiate will be this side. Which one will be traveling faster now? Obviously will be the one that is furthest. That is star B. So B will be having this one, the lowest frequency, and will be traveling the greatest now. So fine, it will travel greater than star A. So C is the best bet in this case. C is the best bet. And then let's go to 1.7. 1.7 is about electrostatics. R and S are two small charged spheres placed at a distance apart. P is a point on the right of star S. ER and ES are the electric fields at point P due to the charges on sphere R and S respectively. See the diagram here. You can see that now ER it's shorter than ES. Of course, yes, P is closer to S, will have a greater electric field strength. Now, which one of the following combination is correct for the net charge on R and S? Remember, if P is now experiencing the field towards S, S must be negative, and if AR is to the right, therefore R must be positive. So we are looking for R being positive. And that the answer is between A and D. What will separate will be S. S will be negative. Therefore, 1.7 should be A. Because we say the field around negative is towards the charge and around positive is away from the charge. You underline that one, then this question will be very easy to answer. Now, 1.8, which is in relation with electric circuits. Remember, question 8 in the structure is electric circuits as well. So the circuit below was used in a practical investigation. The battery has an EMF and internal resistance R. Ignore the resistance of the connecting wires, graph K and L below, obtained from the readings taken. Fine, no problem. Now if you look at K, then in this one K, the voltage and this one are directly proportional, whereas in this one now the two are proportional. So you can see when the current increases, the voltage decreases. Which one of the following combination below indicates the voltmeter reading taken to obtain K and L? In this case now, the one that will be having resistance, internal resistance, will be the second one, which is graph L, I think. Okay, fine, let's look at this one. In graph K, what will be the, in this case, V1? If graph K is, you have got V1, and then in graph L, so we must get your V2 in this case. So let's check the graph K. The V2 would be the one, the reading for the relationship, because when we are dealing with Ohm's law, we are looking at the voltage across the component, which is your resistor here. Voltage across the component, which is this resistor. And then in graph L, then the voltage that will give us the reading will be the one, which is the V1 now. So which means that now C becomes the best bet in this case. V2 will give us the Ohm's law, and then here V1 will be the one that is the, remember if you use the formula of EMF equals to V plus IR, that is, this V is the external load, which is your V1. So but if you use R equals to V over I, therefore the V is across the component R. So that's why now we'll have a V2 and V1. So C will be the best one. C becomes the best one. We go to 1.9. Which one of the following in this case is the function of the split ring commutator in an electric motor? Remember, the split ring is the one that normally we say it reverses the current every 180 degrees, or in this case to just provide the DC current. Split ring commutator rotates the coil. Split ring commutator in this case delivers the current from the coil to the external circuit. Split ring ensures the coil rotates continuously in one direction. Yes, we say split ring commutator produces what? DC current. So it shows that now the current flows only in one direction. So C will be the best bet in this case. And then the last question in this one will be this one in the multiple choice here. 1.10, which one of the following statement correctly describe the photoelectric effect? Remember, the photoelectric effect is the process whereby electrons are ejected from the metal surface using the energy of radiation that is incident to the metal. Fine. So an electron absorbs the energy of a photon in this case and emits light. No. Electrons emit a photon when it collides with another electron. No. An electron will absorb energy of a photon and is ejected from the metal surface. That's the best one. So electrons in this case will absorb an energy from a photon and then eject an electron from the metal surface. The last one says photon is emitted when electron moves from a lower energy level to higher, which is wrong. So the electrophoton is emitted from higher to lower. So the best bet will be number C. So therefore number 10 will be C, to say during the photoelectric effect we say energy from whatever source of radiation, and electrons, since are floating here, they will absorb the energy and then emitted, ejected from the metal surface. That's the case. So I hope and believe that this one gives at least an idea of how to answer multiple choices now in this case. So let's pause and then we'll continue with this session in the next few minutes. Thank you.